Hello, everybody. My name is Calvin Wu with my teammates Haris Halim and Alexandro. Today, we will be presenting our research poster on our research paper, which is a curated multi-source model dataset and benchmark for single-view 3D reconstruction models.
Single-view 3D reconstruction aims to generate 3D objects from only one 2D image. Although modern feed-forward models have improved rapidly, they are usually evaluated on large multi-category benchmark. This aggregate result can hide how well a model performs on one specific object category. This study focuses on battle because they appear across many public 3D asset sources and have recognizable shared structures while still varying in shape. This research built a curated multi-source dataset and uses it to benchmark modern single-view 3D reconstruction models more specifically. The objective is to evaluate how well single-view 3D reconstruction models perform on the battle category by using curated multi-source dataset, standardized preprocessing, and consistent evaluation metrics. Single-view 3D reconstruction has advanced from fossil-based method to modern feed-forward models such as OpenLRM, LGM, and splatter image. However, many evaluations use aggregate multi-category benchmark, which can hide object-specific performance. This study addresses that gap by focusing on battle-specific reconstruction. Motors models were collected from ShapeNet, ObjFirst, Sketchfab, and Thingiverse, then processed through a standardized creation pipeline including format standardization, category verification, duplicate removal, normalization, quality control, and shape classification. The result dataset was used to benchmark PixelNerve, OpenLRM, splatter image using volumetric IOU, chamfer L1 distance, and normal consistency as its evaluation metrics.
So, from our methodology, we got our results and findings, which are the results show that the model performance varies depending on the evaluation metric. OpenLRM achieved the strongest volumetric IOU, indicating better global shape overlap with the ground truth bottle models. Splatter image performed the best in chamfer L1 distance, and also normal consistency, showing that it has stronger surface proximity and surface orientation alignment. Pixel Nerf showed weaker overall performance under the same evaluation setting, especially in global shape reconstruction. Our data was put in two tables, which the first table is quantitative comparison on the bottle test set, where you can see each model's IOU, chamfer L1 distance, and normal consistency values. IOU and normal consistency is better when it is a higher value, and chamfer L1 distance is better when it is a lower value. On the second table, which is the stratified reconstruction performance by bottle shape subgroup, you can see each model's IOU, chamfer L1 distance, and normal consistency values for each class, which are straight, tapered, contoured, bulb, and other.
Alright, the next one is for the analysis. The finding shows that the single-view 3D reconstruction performance cannot be judged using the only one matrix. So OpenLRM is stronger for capturing the overall bottle volume, while splatter image is stronger for surface level reconstruction quality. And then the shape-specific results also shows that bottle geometry affects reconstruction difficulty. Regular shapes such as straight, contoured, and tapered bottles are reconstructed more reliably, while irregular bottles shape produce weaker results across all of the models. This suggests that category-specific benchmarks provide the more detailed insight than general multi-category evaluations. And then the last one is the conclusion. So this study shows that category-specific benchmarking gives clearer insight into single-view 3D reconstruction performance. On the Badal dataset, OpenRM produced the strongest global shape overlap, while Splatter Image achieved better surface level reconstruction quality. And then the results also shows that the bottle shape variation affects the reconstruction difficulty, with irregular bottle geometrics being the hardest to reconstruct across the evaluated models. And then for the future work, can extend this benchmark to the other object categories and include real-world input image for practical evaluation.
That is it for our poster presentation on our research paper. Thank you.